All right, so the BD787, I'm not too sure I got this in the camera, but it's showing this is the way it's looking at the device with the heat sink, and it calls this lead 3, 2, 1. And then I guess hopefully you'll be able to see on the data sheet that's on the top page. On the last page, sometimes you have to look at the package drawing to figure out what they are. On the last page it says 1 is the emitter, 2 is the collector, 3 is the base. So it goes base, collector, emitter. Go ahead and pull all the wires. We'll set the part in there. And we are going to...
NPN?
Yeah, this is going to be NPN. So we're going to set the wires to the base, collector, emitter. Yeah, see, the breadboard's handy for being able to do multiple devices, and go in and out. Versus, because you could clip the leads right to the wires. Okay, so we have that set. We kind of start back with low current, low voltage, always the beginning. This device is an NPN. Once again, you can see your polarity. You go to NPN. And now we got to move everything down here to the corner once again. So now we're all set. We want to look at the VBE. Remember, base shorted to the collector, for the VBE. I have a drawing here. Hopefully, we'll save this page. And we're looking for 2 volts at 200 milliamps. And so 2 volts at 200 milliamps. We'll probably go something like 50 milliamps per division, and a half a volt. So let's see here. Here we go. We're going to half a volt. Oh, actually, I'm going to increase this. Now, see, we don't have good resolution. We're only 2 squares. We got plenty of room on this. So let's actually move further out, and then we'll try it again. And we're going to move to there, and let's count again now. 0.1, 0.2, because we're at 100 millivolts per division. 0.3, 0.4, 0.5, 0.6, 0.7. Now we're starting to turn on. We'll count current going vertically. 50 milliamps, 100 milliamps, 150, 200. So we are at 1, 2, 3, 4, 5, 6, 7, 8. So we're at about 0.84 volts at 200 milliamps. So, this is, kind of very well in the operating range for the VBE. Yeah. So now simple, we're going to go to check the collector to emitter breakdown. This one actually is a 60 volt device, but it has a 100 microamp spec. So we're going to take the base, which is now shorted to the collector, bring it down here to the emitter. This ensures the transistor is off. Now we'll try and set our supply to at least go to 60 volts. We'll move the max peak up to 75, and we'll set our voltage for 10 volts per division to start with, and we'll go down to 20 microamps per division. So let's see what the breakdown is. 10, 20, 30, 40, 50, 60, 70, 80, 90, and we're not going any further. So now we got to turn off. We'll go to 20 volts per division, increase our supply. 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. What's going on? Go to 50, 50, 100. Oh, yeah, I think we're live. 50, 100, 150, 200, 250. Wow. So, see, this is a this has a breakdown of 250 volts at 5 squares will be 100 micro, and you know, basically it's still 250. And this is the reason why you won't see current a lot of time rated on the breakdown, because it's no matter what it is, even if at 2 microamps it's 250. At you know, at 50 it's just minimally higher. So essentially this number does not really change much. You know, it's still pretty much what you're looking at is the point where it breaks, and you know, it's usually never spec'd above in 250 microamps. You know, but essentially, if it's 250 microamps you're measuring, or you know, from 10 microamps, it's still going to be 250.